I will finish يعني. on Wednesday inshallah I will scan it and I will bring it. Okay. Homework. You did great. No, you should have been sent. No, you didn't. What else? Project wise. A group setup وخلاص finished. الحمد لله. Yes. The project, weren't we supposed to do AM? What? No, we said this time FM only. Didn't we discuss that we wanted us to do hands-on, so it's going to be AM? No, but in the lab we said it's FM. Yeah, I know that. I was like, you wanted AM, so I was like, no. Maybe you don't hear us properly from there. I'm sick, doctor. I'll get you sick and then holiday. I don't care. Come. No. عشان بس instead. Okay. So today first. This was the. Okay, let's make a small review. Then what is all of this? So modulation. Last time we started with the modulation. Okay. I will review with red. So we said that we have these ones that are not widely used, this one heavily used. So we started with the PAM. We said that the different symbols are distinguished by their amplitude. Okay, so here symbol 2 this amplitude, symbol 3 a bit more, and so on. The black is the good one, and red is whatever is received because of the noise of interference. So we said this is a drawback, the distance, because you can send here. Okay, good. As 1 watt and receive it as 0.3 watts. So we will have an issue with the distance. It is a bit more complex, but yeah, it is still feasible. We saw that it is written like this. What is it? SAM G of T, where G of T is the shape. Okay, and the most famous one is the rectangle. Well, I see that, yeah, we comment that in a practical system is not a perfect rectangle, but with some roll off, because in the frequency domain, we cannot afford something called infinity. We realize it is not orthogonal. Okay, perfect. Okay, what else? We commented that they are the energy. What is the energy? No, we have to say that it's not equal energy. Okay, good. So here setup A and B is about the energy. Okay, so you have always to try to make the shortest distance to the origin. Good. Okay, and we concluded it is not orthogonal. Yes. I will come to it now. Okay. I said even the same stuff last time. I will explain it now. So here this is the PAM. Okay. Before I do that, this is the revision. So I will start a new set of slides. So you distinguish between them whenever you will study. You all have access to whatever we post. Anyone facing issues? Good. So whenever we would like to put them as, we said that they are not orthogonal. So all of them, they share the same phi of t. If this is the 0, okay, then in order to guarantee the least power or energy, we put them close to 0. So the first option will be to put them like this. So symbol 1, symbol 2, symbol 3, symbol 4, symbol 5. Okay, but we said this is not energy efficient. So to make it energy efficient, this is the way that we will do it. So this is the 0. So we'll make them like this. Okay, so this will be S1, S2, S3, S4, S5, S6, and so on. So here the 0 is centered. Good. So here the idea of having the 0 centered, it is just as we said. Okay, so here to achieve better energy efficiency. They will have exactly the same performance, but only with less energy. So here, this second option, it will be with less energy than the first one. So here it's called it A, this one B. So B will be less energy consuming, so it is better, okay, and showing the same performance. This is the same as for the GFT. So we just drawn the GFT like this, and we said this is the GFT, okay. Can't be made like this, okay, and it will be the GFT. Actually, this is more practical, okay. Why? Because later today we will see a signal that is, for example, all the signals, whenever we want to send them, we have to load them on a cosine, okay, so that it can propagate, okay. So in order to propagate, the cosine has a positive part to negative part, okay. So having a positive part to negative part, it is more suitable for this one, and it is more suitable for this one. So do we have something called negative power? No, we don't, okay, but it will be better as a representation, okay, for this one. So here we can even in the book they write it like this, okay, square root of the energy and minus square root of the energy. Again, do we have something called negative energy? No, we don't, okay. Principles of physics, but yeah, it is better as a representation, okay, to say that this is on the axis, okay, and we have the zero centered on the middle. Good. So by the way, why they put it like this? Where it came from, this energy? Why square root of the energy?
Normal.
That's it. So instead of putting the distance, so from here to here, D, and we know that distance square is equal to the energy. So D is equal square root of the energy. This is why in the book they wrote it like this.
In approach B, it's better energy or less?
Yes, here the B is less energy consumption. So better energy efficiency.
What do we mean by these two functions?
Which ones? A or B?
GFT.
GFT or GFT? Ah, this one. So the GFT, today we will see, whenever I want to send a signal, I will send it over a cosine. So all of this is what we call baseband. I will explain now. So we will see that inside there is a cosine to be sent. And the cosine by itself, we know that it is like this always. So it has a positive part and negative part. So it is just definitions. Good so far? انت you switch the team ولا شو القصة؟ okay, good. Good so far? Clear this point? So for the PAM, to sum up, PAM, good stuff and bad stuff, advantage. Shab.
More power efficient or energy efficient?
More than what? More means better than something else. ما هو عشان هيك I need something to write now. Yusuf. Any advantage that you remember that we have discussed? Oh, disadvantage. I will accept anything. Bath loss, شو ماله? So it is affected here. It's a disadvantage, this one. It is affected by distance or path loss. Good. This is a good disadvantage. أبو عسل. Advantage or disadvantage? Oh, good. It is not orthogonal. So if it is not orthogonal, what does it mean? There we will have some interference. Yes. What does that mean? Yeah, it's good. It's complex. Whatever. خلاص. Interference. We know interference is bad. طيب. Advantages, guys. Anything?
Can you increase the number of bits transmitted?
Yeah, this is for all modulations.
System become more dynamic.
Why?
Because of increasing more bits to do that when we send
But this is for modulation. So the idea of modulation is to send more than one bit at a time for all modulations. But for PAM only, No, ما حكينا distance. Anyone?
The concept is simple. And compared with the
What? I don't hear you.
he said less interference.
Better that I don't hear you then. Faiz, Ahmed.
We combine and send this type. We combine in one
Symbol, we send more than one bit. Yeah, but this is advantage for modulation, not only for PAM.
The concept is simple.
Simple. Simple, low complexity. But on here, it is more complex. Yeah. What is the level of complexity? I don't know. You have to calculate. By the way, how you measure complexity? Yes, whenever we say this is complex, how we know this is in the processing? So yeah, so you have seen this in digital systems? Not yet. No, for the whole course that, right?
Some of us finished it, some of us finished.
Okay, good. So, in order to measure complexity is, as your colleague said, is the number of operations at the processor. The guys who study computer engineering, they know more about this calculation. But you, with your knowledge, okay, you will be really fine. Okay. Good so far? The number of operations at the processor. مين عبد العزيز طالب؟ Not here. Done? Can you continue? Okay. So the next one is an upgrade. It's called in the book. They call it band pass. Band pass PAM. Do you know what is the band pass?
Yeah.
What is the band pass?
And
Okay. So this, in other words, PAM at high frequencies. شو مالك؟ What? It's band pass. It's called. It's a band. Okay, at higher frequency. So band pass, and whenever they explain to you electronics, it was like this. So this is low pass filter. If this is the end of the frequencies in the word, this is high pass filter. Band pass, it was at some band. But yeah, here everything electronics, hardware. احنا here software guys. عبيدة. All good? Okay. What is this band pass? I need to explain the motivation. Motivation for the band pass. Good. Let's make a review because today in the female I was shocked, okay? Your mobile phone, how many technologies does it include for communication based on your information? Yeah, GSM يعني 2G و 3G و 4G و 5G. بعدين غير Wi-Fi. Bluetooth. I said communication. Cellular, the first four, yeah. GPS, it is a receiver, it's not a transmitter. I said communication, and antenna, it's a device, yeah. It's a unit. Do you have NFC in your phone? What is NFC, Tayyip? Yeah, it stands near field something. Near communication, أكيد, yeah. But يعني, I don't care about what it stands for. I needed to know what is it for. بالريموت في ريموت تلفونك sorry بالكارز bank card, yes, good. So this is for the what they call it, contactless payment through phone. Do you have any one of you the card on his phone? Why يعني هيك منظر هذا؟ Yeah. Yeah, good. So it is يعني very convenient. So this technology, the near field communication, okay, you have it on your phone, you come closer, okay, and you can pay it. Okay, this is يعني a high security, low coverage. It has its properties. Good. Thank. Whenever your mobile clear, more technologies on your phone. What? More technologies on your phone.
Radio.
You have a radio on your phone? You have a radio on your phone?
With the headphone.
والله كويس, good. And it connects without being connected to the internet? خلص زي هيك. You have radio on your phone. What is that phone?
Samsung.
Yeah, Samsung one. أكيد مش Apple. A10. Yeah, very good technology. You can break it and have your project منه FM. Okay, good. Stay there أحسن. Okay, good. So whenever your phone wants to communicate with all of these stuff, okay, how it will distinguish between them? On the frequency. Good. So whenever your mobile phone, imagine that you receive a call from Ooredoo Tower. Okay, this is your mobile phone. Okay, and you are using your AirPods. Good. So there is a communication here between your phone and the tower of Ooredoo, but also from your phone to the AirPod. Good. And also maybe your phone is connected to the Wi-Fi here. Maybe you are in the room, you receive a phone call. So and you are downloading something from there. So your mobile phone is connected to the three of them at the same time. How it will do that? Only through frequency. Okay. So and how is that? We have, this is the frequency, all the frequencies. So here the frequency for 2G, for 3G, for Wi-Fi, for Bluetooth, another one for Wi-Fi, and so on. By the way, do you know about versions of Wi-Fi? What, like? Good. Okay. والله أنا يعني okay, happy. Good. Wi-Fi. What is Wi-Fi 6 يا أحمد فايز؟ بطلت happy. Yeah. What is Wi-Fi 6? Hamza. Do you have Wi-Fi at home? Okay. What is the name of the internet that you have? اسمهش حمزة أكيد. يا وي. طب يلا. نسميه حمزة. Do you have حمزة وحمزة 5G ولا لا يا حمزة at home? What is the difference between them? Do you have this at home? محمد شكله مش عندك.
يا طارق.
ايه؟
والله ما ادري بس اشبك.
طيب. يعني whenever you have it at home, so the router, the name of the connection, okay? Imagine it's called Hamad. Okay? It doesn't have Hamad 5G.
Yes.
You all have it at home?
Yes.
Oh, what's the difference between them?
5G is less area but faster.
Okay, good. So imagine you have two connections, Hamad and Hamad 5G. This one will be more data rate, but less coverage, as your colleague said. Exactly, okay? By the way, it is not 5G. It's a trick. It is 5 gigahertz. Why they say it 5G?
To make it look like it's.
Yeah, it is more commercial-wise, okay? Yes, Sabaida.
Filled data rate or required data rate?
Filled data rate. Okay, so here it is 5 gigahertz. So here this one is operating at the 5.2 gigahertz. This one is operating at the 2.4 gigahertz. Okay, so and Wi-Fi 6, it is here. This is the Wi-Fi 6. So what is the official name, ya Ahmed Fayez? You go to Virgin here or to Carrefour? What to do what?
Just to look.
To eat M&Ms and leave, right? Expensive. طب لا, why? How you distinguish between the stuff?
Alibaba. What distinguish what?
طيب خلاص, okay. It's my mistake. Okay, good. So whenever you this what is the key word of engineering? Yeah, who attended previous courses? Hisham, what is the key word in engineering?
Optimization or curiosity?
Curiosity. This is the one. So it's said that engineers, not only electrical engineers, okay, they should need to have curiosity, okay, to want to learn. So whenever they will go to find new product, to ask or to read what is written on them, okay. So the Wi-Fi, the official name of the Wi-Fi is called the IEEE standard, IEEE 802.11. So the old one now, it's called the N, okay. So if you want to go and buy N, it's been the old one, and now we have the new one, which is called AC. Okay, so the guy who will sell you the router, you should be able to read what is written so that you distinguish. Maybe he is simply lying to you. Okay, so I don't know, يعني أو يمكن أنا myself يعني I'm a nerd يعني, but يعني I like to go and check what is new, what has arrived to Qatar, okay, what is the operating for this, what is the operating for that, so that I know what is in the market. What I expect you to do. Good, Hisham? Curiosity. Good. طيب. فهي this standard, okay, is at different frequencies. So whenever your phone wants to connect, then it will connect over 4G to receive a call, or 2G to receive an SMS. Okay, it could happen while you are talking, you receive an SMS. It is connecting to Wi-Fi, downloading something, and you are talking or listening to the voice call through Bluetooth AirPods, which means that your phone is connected to several of these stuff. And what is the only way to distinguish? Frequencies. Okay, this is why they said we need the PAM to see it at high frequencies, and the only thing that will make the signal to travel is sinusoidals. Sinusoidals here will make the signal to, what they call it, travel. So if you put the signal on a sinusoidal, okay, the sinusoidal by its nature doing this, okay, it will go. Okay, ideally it should reach infinity. Practically, okay, there is some resistance from the air, so it will stop. If there is no air, it will continue. Like radiation, external radiation. Okay, so satellite to satellite, for example, satellite to exploring UFOs or whatever. Okay, the signal is in free space. They send the signal, and the signal will continue until forever. Good. So this is thanks to the property of the sinusoidal. Clear? Good. Where have you seen sinusoidals in previous courses? Circuits 2. What was where you have seen it in circuits 2? So the source is here, a voltage source that is sinusoidal. How it was looking for? Yeah, Ubaida. Good. Okay, so the frequency is inside the cosine. So here, whenever we go for this bandpass PAM, instead of our rectangle, this one or that one, okay, now it will be like this. To put an example, this is a G of t. G of T. To put an example, so here let's see a sequence of bits of symbols to be sent. S1, S4, S2, S1, S3, and so on. How they will look like? T, 2T, 3T, 4T, 5T, 6T. Good. So, in the first interval, it is S1. On the second, S4. So, 1, 2, 3, 4. S2. S1. S3. And so on. Okay, so here, if I change the color to blue, you see here, this is the amplitude for the first one, amplitude for the fourth, amplitude for the S2, amplitude for S1 again, amplitude for S3. Good? But now it will be a sinusoidal. That what is difference? We don't change the frequency, okay? We only change the amplitude. Good? So a question today from one of the female students said, so the number of copies inside here, it will be the same. So here, if I have how much? 1, 2, 3. Yeah, it will be the same. Okay. Same frequency. So here, the only thing that changed is the amplitude. So here, this will be A1 cosine 2 pi ft. This will be A4 cosine 2 pi ft. With this one, A2 cosine 2 pi ft, and so on.
Could you repeat what did you mean by having different amplitude?
Here? Okay. So notice that this is the sequence that I want to transmit. S1, S4, S2, S1, S3. Okay. It is PAM. So what is the difference between them? Amplitude. Okay. So the amplitude for S1. So here, this is the amplitude for S1, amplitude for S2, amplitude for S3, amplitude for S4. So the amplitude for S1 is this one. But yeah, we said it is bandpass, so sinusoidal. Then here, this is the amplitude S4. So the amplitude of S4 is this one. So here, sinusoidal up to this amplitude. Then here, S2. So this is the amplitude of S2, sinusoidal up to that amplitude, and so on. That's your question?
You said that.
In the previous lecture?
No, you said, for example, you said the features that we have in our phones, they use different frequencies.
That's it.
Why not here?
So here, this one is, imagine that all of these are for Wi-Fi. Okay, so it will be the frequency for Wi-Fi, the frequency for Wi-Fi, the frequency for Wi-Fi. I want to transmit another signal for Bluetooth. So it will be another one, maybe another sequence. In Wi-Fi, you are downloading a video on YouTube. On Wi-Fi, on Bluetooth, you are making a phone call. So the sequence of symbols is different, right? So it will be another shape with the frequency of the Bluetooth, and so on. So the motivation here is that each system has a different frequency. But yeah, once you are you select the system, here it is the same frequency kept. That now answer the question?
The same frequency?
No, we send them at the same time. So, yes. So, this is why actually your phone, again, it can download. You can make a phone call or receive a phone call. Okay? Everything at the same time, and you will not notice. How we distinguish between them? Because each one of them has a different frequency. And in each frequency, there is a stream for Bluetooth, stream for Wi-Fi, and so on. That's your question? Answer? You follow us? Sure? What are you doing? Oh.
So here in Wi-Fi, here we will use Wi-Fi at the same time.
At the same time as another system. So here, this is for Wi-Fi. For Bluetooth, imagine instead of S1, S4, you want in Bluetooth to send S3, S1, S4, S10, S1, and so on. So here for Bluetooth, you will have for each one of them at a different frequency, and here it will be A3 cosine 2 pi f of the Bluetooth T. Here it was frequency for the Wi-Fi. Answer? Hani. Clear? Amir.
How many processors do you need to run on the system?
So many processors. This is one, well, everything here can be handled with one processor. But yeah, what is the capability of the processor? I don't know. But yeah, now you know that almost all the phones in the market, they come with multi-processors. So it's not only one single processor. So many processors at the same time. Answer? Usama.
And we have the same.
Just guys. Yeah, Annie. Why you don't ask before I ask you?
I was about to ask.
Okay, good.
And you have the same amplitude from the same frequency. For example, two different connections, Wi-Fi 1, Wi-Fi 2.
They could have Wi-Fi 1, Wi-Fi 2. If we have more than one connection over Wi-Fi, that will be another story. We need to separate between them something else. Maybe it could be also within the band of the Wi-Fi, two different frequencies. But yeah, this is another story. This will be multiplexing. I will explain it later. Yes.
So, Doctor, I'm a little bit confused. The example you told us before of mobile phone and this one, these are two different methods?
No, it is the same. So here. Where was it? Well, it's here. Your mobile phone. It is connecting to Redo. It is connecting to Bluetooth. It is connecting to Wi-Fi at the same time. Okay. So over Wi-Fi, it is sending PAM. Here it is sending PAM. Here is sending PAM. Symbols here, symbol here, and they are not the same symbols, right? So when the symbols that are sent over Wi-Fi, imagine this is the sequence. You are downloading an image. Okay. So it will be this is the sequence and at the frequency of the Wi-Fi. For the Bluetooth, you are sending another sequence. And it will be at the frequency of the Bluetooth. Answer? Confused? Shahab? Fakhro? All clear? Questions? Okay. So, next modulation family called PPM, which is pulse position modulation. Where is the keyword? Position. What is the idea for this one? They want to solve the issues from the previous one. Okay, so here they said this was like a next step. Okay, so here we want same amplitude. So here fixed amplitude for all. So no problems with distance. We want equal energy. So what we said here, we need all of them to be equal energy so that the
Equal distance.
no, I explained this to you last time or not? No, why you need the same energy to all? No.
So you choose the equalizer.
No. Okay, good. So it seems I have not. Okay, so we always prefer to have a system that is equal energy. So all the symbols with the same energy, so that the energy is not changing, so that the amplifier is easier. You have seen amplifiers, right? Okay, and you know that for the amplifier, there it has a region of operation. Which region do you prefer in the amplifier? You prefer saturation? Linear. You always prefer the linear region, okay? So if, for example, a system here, PAM, the energy was different because your amplitude, another amplitude, and so on. So maybe with this continuous jumps of amplitudes, you are not always on the good region, okay? While here, if you have all of them to be equal energy, it's much easier to know what is your good region. It's the same, okay? So it is one single value. So the amplifier design is much easier. You also did electronics here? You studied the amplifier and the electronic? Saturation? linear? شو يعني the information is different? Okay, good. Okay. But obviously there is nothing for free, so this one will come with its own problems. Here the disadvantage that I will explain is called synchronization. So this system is not better than PAM. PAM is not better than this one. So which one to use? On the system that you have. So you as an engineer, they will ask you, we have this issue with these problems, okay? What to do? Sometimes maybe the other one is better. Sometimes this one. Sometimes the next one will be better, and so on. Cool? So all the systems are good. All the systems are bad. You are the ones who will decide. Good, ya Basel? So how the system will work, as its name, position. So they did the following. Let's see, where can I draw? Here. 1, 2, 3, 4. S1, S2, S3. Imagine we have 4 symbols. 1, 2, 3, 4. How we will distinguish between the symbols? By the location or by the position. How is that? If it is sent at the beginning, we will say it is S1. لا كتير هذا صغير. If it is in the middle, this is S2. It is on the other middle here, and if it is at the end, this one. So here, all of them with the same amplitude, A. Okay, but the location or the position of each one is different. In PAM, we didn't have position. So in PAM, for example, it was like this. All of it with different amplitudes. Okay? Now here, not all of it, but just some part of it. For example, if I want to send a sequence, what is the sequence? S3, S1, S4, S1, S2, and so on. How it will look like? T, 2T, 3T, 4T, 5, 6. Okay, so the first one is 3. It will be here. S1, it will be here. S4, it will be here. S1, it will be here. S2, and so on. All of them with the same amplitude. All of them same amplitude, but where in which part of the time we send it, okay, that will be a different symbol.
When we send S1 first day in the position.
So here is the sequence. So you have this sequence of symbols to transmit. So for each one of them, you will come. This is the first time interval. I need to send S3. If it was, for example, PAM, and let me change the color to blue, what you will say, this is the amplitude for S3. Then in the second one, it is S1. This is the amplitude for S1, and so on. Now here we don't do that, but how we will make the how we will help the receiver to know if it is S1 or S3 or S4 by the location. So we will say to the receiver, if you detect the signal, because it's the same amplitude, okay, so the system cannot distinguish between them, okay, but if you detect it on the third interval, this is S3, on the first interval, S1, and so on. So the sequence will be sent, then stop, sent, then stop. Notice that here the stopping time could be different depending on what is the sequence that you have. That was your question or not? Is it clear?
So the bits can vary.
Yeah, here the waiting time is variable. Variable based on what? Based on what is the sequence, on what is the video, what is the image, what I want to send. So here you cannot control this one, but you don't care. So here it is. You are transmitting zeros only for a specific time. You transmit ones, zeros again, ones, zeros all the time, and so on. Clear? Yes.
So here, like we have different frequencies.
Here, no, it is same frequency, same amplitude. So here, this system has same amplitude, same frequency,
We can detect it by the position.
different position, or different timing.
For the previous one, we can detect it by the amplitude.
The amplitude. Hamad, you follow us? Sure? Yes, please.
But there will be always a delay between each signal, right?
Delay between what?
Like S3 and S1.
Yeah, definitely. So if for example, I'm hearing the receiver, it will send the signal and it will shut up. Send, shut up, okay? And this shut up time is variable.
T is fixed.
The
The T.
T, yeah, this is the symbol time, it is fixed. Is it clear the scheme? Muhammad Noor.
It would save more energy, right?
This system will save energy. So here, advantage for this one. Advantage, more energy. وهلا here more, we can more energy efficient than PAM, because now we can compare. Where's Khalid? Missing today? The two Khalid missing today. The three of them. مين عمر؟ عمر؟ Not here. Muhammad Razul, I have not seen him. Okay. Do you see questions? Questions? Do you see any problem for this design? Which is distance of what?
Like in the signal itself.
So it turns on, off, on, off, on, and so on. But it's fine. It's not a problem.
Can I shorten the distance? Can I shorten the distance?
Can you make it shorter the distance if you decrease this one? Yusuf.
It will take longer to get the information.
It will take longer. It is exactly the same. In PAM, and let me change the color to, let me clean first of all. So in PAM here, to send, which was this one? S3. So S3, but then S1, بعدين S4. So the same amount of data will be transmitted, exactly. So the same, both of them. Any issue? Same.
Because here it's like same amplitude, so comparatively to the time it's more complex.
Again, same amplitude, so?
So it is more complex than PAM because the amplitude is same.
Keeping it the same,
Keeping it the same is good.
but complexity also comes into it, right?
The complexity from amplitude, there is no complexity from amplitude. Muhammad.
Maybe the more symbols we take, less the width, so that we can put a certain amount of positions. This may be harder.
Definitely. So here, the number of positions is controlled, okay? But the same with PAM, so you cannot have infinite number of amplitudes. Slower? It is the same. You can send the same amount of symbols, so it is exactly the same. Abdul Ghani.
In the 3T, how can we detect if it's on or off?
What are?
You know that the symbol has to start from here, finish to here. Then you detect it at the end, so S4. Then from here to here, you know that you should receive another one. You detect it at the beginning, so you know it is this one. Hisham. Amplifier is the easiest. So here. Good. So what is the problem with this setup? Okay. أريد تاور أحمد سعيد. Good. So here signal to Ahmed or signal to Saeed. Different distance, right? But here we said that the amplitude, we don't care if it decreases because it is not about amplitude. But it depends on something else. We know that D equals C times T. Do you remember the stuff? No? Alhamdulillah. Okay. Distance equals time multiplying speed. Highest. Distance equals time multiplying speed. Here, what is the speed that we have for our signal? Speed of light. This is why I put a C. Good. So the distances are different. The C is the same. So the C here is the same as the one here, which means that the T keeps same. It will be D1 over C, and here T, it will be D2 over C. This is why this is T2, this is T1. So the time for the signal to arrive is different. Do you agree?
Yes.
Do you agree so far? Let's see how this could be a problem. Good. Imagine I have an ideal system. Ideal system. Here I have user 1 who wants to send what? Symbol 2. So here, this is the time. This is the transmitter. This is the receiver. So here, symbol 2. And another user here. This is user Ahmed. This is user Saeed. Right? So Saeed, he wants to send S3. Good. So ideally, what I will receive, the receiver will receive for Ahmed, it will receive S2. And for Saeed, it will receive S3. No issues. For Ahmed alone, for Saeed alone, the system is perfect. Ali, what are you doing? Don't touch the phone. Okay, so clear, sure, perfect, good. Questions about the ideal setup? Questions about the ideal setup? Saleh, all clear? Let's go practical. In the practical one, again, I want to send the same stuff. Okay, so here, Ahmed, he wants to send S2. Saeed, right. S2. Saeed, he wants to send S3. Good. Now I will make it with more time. So if all of this is 1 millisecond, so if I want to divide in 4, okay, good. So this is 0.5 or 0.25 or 0.5 or 0.75. So here 0.25, 0.5, 0.5, 0.75. Good. In a practical system, whatever I will receive from Ahmed, which one is Ahmed? Ahmed, let's say this is Ahmed. And this is Saeed. Good. So the signal that will come from Ahmed, what will happen to it? It's a long distance. So it will take more time. So the signal that will arrive from Ahmed, it will be from 0.3 to 0.55. There was a 0.05 delay because of the distance. Okay, but the signal that we will receive for Saeed is closer, so the distance is less. So the time needed is less. So the one for Saeed is from 0.51 to 0.76. What do we have here?
Delay.
Yes, we have interference. So yeah, both of them, they have delay. So here the delay equals how much I put? 0.05. Here the delay is 0.01. and I cannot control the delay because this one is far, this one is close, okay, and this one can move. Whenever you make a phone call or you download something, they cannot tell you, well, stand still, you cannot move. You're moving. Good. And the same for this guy. So here, the delay is something that you cannot control as a designer. Good. So here, this one is different from this one. But now here, as your colleague, he said, what do we have? Why do we have interference? There is an overlap between 0.51 to 0.55. This one has not finished. This one has already started. Okay, why the system here? This should finish. This should start. You see, it's finish, start, finish, start, and so on. So it is perfect synchronization. Here, the system is not synchronized, so we have interference. And whenever we have interference, we have bad quality, bad data rate, bad everything. Do you agree? Ahmed Faiz. Sure. Hamad. Clear? Board? Nasan? There was a match yesterday? Yes, there was a match. 7 matches? Wow. كمان. Why you are not wearing Manchester today? Good, so clear this technique. When you will use this technique, Tayyib? In which scenario do you think that this technique can be used? When the distance is fixed. Good. So PPM is suitable if distance is fixed. Examples. What? Ohms? At home, but I don't understand. What is the case? From Ooredoo to?
Yeah, like making Falcon home.
So يعني they will know Hamza, he is at home, so we will set up this system for him. Hamza طلع من الهوم أكلنا هوا. We need to change another one.
Between an Ooredoo tower and the base station, for example?
Again?
Between an Ooredoo tower, for example.
Okay, good. So this is a good point. So this is a tower for Ooredoo at the university. This is a tower for Ooredoo at the gate of the university. Both of them are fixed. So here, in theory, PPM will work. In practice, it will not. Because this PPM is characterized to be here suitable for whenever the distance is fixed, but also it is suitable for low data rate. Why it is suitable for low data rate? You see here, where is it, the plot? A lot of time that is not doing nothing in the system. Okay, so it's going to be a lazy system. Okay, so the data rate is low. Between base station to base station, a huge amount of data is flowing. Okay, so this system does not work here. This system works in another place. I commented about it last, I don't know, but some lectures ago, I commented about the use case. I need a use case whenever the distance is fixed, so receivers are not moving, and there is no need for large data rate. Old phone? Old phone? I don't remember. I said this example? لا no مش good. Submarine. So the submarine. Wait. No, so they are fixed. The submarine. What?
They can be.
Yeah, and they cannot be. Okay, good. Yeah. Anything that comes to your mind as a use case? Okay. So this PPM some time ago I commented to you about Arzan. Where are you? Why? خلص stay here. Guys, I assume يعني you are 20 years and older, okay? فيعني no need to go to the go. Erzan. I saw another one. تعال. أسامة. فكرت أنت. خلص روح يا أرزان روح. You can go. I want to talk to you after the class. Okay, so Kahrama readers. I remember I told you that now Kahrama in almost all places in Doha, they don't send someone to take the readings, okay? They get the readings automatically at their headquarters. How? They have to communicate, okay, between the Kahrama controller to each one of the homes. Are they moving these homes? They are fixed. They need large data rate? Why? It's a reading, so it is a low data rate, okay? There is no need to transmit la video, wala image, wala whatever, okay? It is only a reading, okay? So the amount of data rate is really low. Not only that, the system will be good, the energy is equal. So it is a fixed energy, this ppm, so it will not interfere with Kahrama energy. Good? This is why this ppm is well, there are several standards, but the one that Kahrama is using ppm. Good? Clear? Actually, the department suggested ppm to be used. Okay, so in 2015, okay, the company doing this, okay, is called Iberdrola. Iberdrola. Have you heard about it?
Yes.
Where is it? Who said yes? I hear the yes.
Yeah, I was searching something, I found this company. They also came for a seminar.
That's it. They came for seminar. We have a good relation with them. Okay, so here, these guys, they are in QSTP, Qatar Science Technology Park, behind Sidra. Okay, so many high-tech companies there. So a good place for you to apply after you graduate. One of them is this one. So here, they were contacted by Kahrama to make the readers. Okay, and we suggested them to go to ppm. It's a good proposal. Go ahead. What he said? What really? It is very old. So yeah, it's very old, but it is yani, fit for the case. Good. They hire so many of our engineers. These guys. Yani, you can apply. Questions? Questions? So conclusion about this example is that does not mean yani, they are old and so on. They can still be used. Okay, and you as an engineer, you are the one who will have to make the recommendation. Okay, not necessarily will I go. What is the best now? PSK. Let's go to PSK. No, wait, maybe there's something better. Okay, even a bit older. Ahsan. I want to talk to you after class. Questions? Clear? Let's go to the next one. FSK. Frequency shift keying. Shift keying is a fancy word just to mean modulation. Why it was used? They call it shift keying, not modulation. If it was called frequency modulation, how it will abbreviate? FM, and they don't want to do that. Okay, that will interfere with something that they already have defined. So they said, okay, let's change the name to something similar to modulation. Shift keying, frequency shift keying. Okay, they call it FSK. This is the one that is currently used in the 2G standard. So whenever now you make a phone call or you receive an SMS, most probably you are using FSK. What is the idea of FSK? Symbol 1, frequency 1. Symbol 2, frequency 2. Symbol F, frequency F, and so on. Good? So here we distinguish the symbols by their frequency. Same sequence. Where is the sequence? Where is the sequence? So S3, S1, S4. So here S3, S4, S1, S2, S3, and so on. How it will be the sequence now? T, 2T, 3T, 4T, 5T. But yeah, now the frequency, first of all, same amplitude. So here, frequency, so here, same amplitude. This is good, okay? Which means equal energy. Thank you. Good. So here it will be with different frequencies. So S3, so yeah, this is the amplitude. S3, then S4, then S1, then S2, then S3, and so on. So same amplitude, the amplitude has not changed. Okay, same timing, the time, there is no change on the time. So here, same timing. So same timing means easy, or no equalization problems here. No synchronization. Sorry, no synchronization problems or issues.
Frequency is different.
But yeah, different frequencies. So we have seen a scheme that will distinguish between the different symbols in terms of amplitudes, or another one in terms of positions, the location, and now in terms of the frequencies. We know that this is not that bad because it has been implemented on a 2G. So it has been implemented by over millions of phones and still being implemented. What is the problem with this one? The number of frequencies here, the frequencies. So here, the disadvantage. Frequencies are, what can we write? Frequencies are not always available. Yeah, good. Frequencies are expensive. Any one of you bought a frequency? You never bought a frequency?
We use it and
You cannot buy frequency. Good. So, who buys, even they don't buy? Ooredoo, Vodafone, these guys, okay? And actually they don't buy, they rent. Why? Because the frequency is called to be a what? National property. Good question. From who?
Government?
أكيد government. But يعني we need an entity within the government. مش هنروح عند الوزير ولا له بدنا نشتري لنا frequencies. بوليس يعني نوقف الشرطه نقول له في عندك 10 frequency لو سمحت. From where they hire the frequencies? ايش؟ وزارة الاتصالات, something like that. Okay, so here in Qatar, what they call them? CRA. Okay, so the ones in charge here of the frequencies, it's called CRA, Communication Regulatory Agency. Also, good place to work. Do you know where is it, يا أحسن? Defna. Yes, it is in Defna. Commercial bank, behind commercial bank in Defna, it's there. There is a court there, right? Court of something. Supreme Court. Yeah. So yeah, again, post. You know the old post office? Okay. In front of it, there is a commercial bank tower. Behind it, the CRA. Okay, very nice place. Okay, to work. Okay, you will develop everything that you have learned here. Okay, and they always hire from our graduates. Good. So the CRA is like it is controlling everything about frequencies in Qatar. Even if you would like to have to bring from abroad a device, for example, what they have an issue recently with for the hooks. No, there is something here that is for hunting. Okay, so they send they want falcons for hunting. Okay, and there are some devices that they will guide the falcon. Have you seen this stuff? No, have you heard about them? Yeah, so they understand, and they yeah, the device is helping the falcon in this stuff. Okay, so the issue with these ones is that usually if they bring them from abroad, I have a friend who tried, yani, okay, the frequencies abroad are different than the frequencies here in Qatar, so they will interfere with so many devices, okay, creating problems. CRA, for example, they contacted the department before the World Cup. They said, we need that for every stadium, okay? They were in charge, okay? For every stadium, we don't need any other guy to come with a device so that they will interfere on beIN Sport signal. Okay, so for example, they hired for every stadium there was an engineer from this department, okay, from a previous promotion, okay, sitting in the stadium doing what? Just monitoring the frequencies, and if there is any frequency that was close to know where is it coming from and move people there. Okay, in every stadium there was an electrical engineer, and I tell you that it was electrical engineer by this department. Okay, so why? To monitor the frequency. So anyone who wants any frequency has to go to CRA. Good. So the price for the frequencies, we are talking about millions. So whenever Ooredoo or Vodafone, they want to expand, for example, they need 10 more megahertz of band, they will charge them millions. Okay, so this is why the frequencies are expensive, not available. So this technique, it was, whenever 2G was there was not a lot of load on the frequencies, so it was good. But after that, whenever they wanted to make an expansion, it was not good. So we will stop here. Next time I will discuss more about the FSK, and then we will move to the last scheme. Questions? Sure. See you on Wednesday, inshallah. Thank you, guys. I need to see two guys. تفضل.
بس الجي بي ام الديسادفانتج اللي هي السنكرونايزيشن.
يعني لما